In this video, we're going to show new features that will be included in Adapt Builder 2018.1, and the anticipated release of this version is February 2019 or March 2019. So for this example, we're going to cover a few topics. We're going to cover new result display settings. These are the red eyeglass settings. That's been organized somewhat differently, more user-friendly. There are a few new options and new hints that can be used to describe certain functions there. We also have new and improved punching shear output, graphical and tabular, and also Excel output. We're going to talk about manual design sections and graphical output related to those. Specific contour ranges that the user can set for any color contour in result display settings. We'll talk about a new option for balance loading using tendon uplift versus the finite element results. And then finally, being able to use the investigation option for crack deflection. And we'll go ahead and start here. We're going to use just a basic model. We'll have Floor Pro Edge and the ability to model post-tensioning, the PTRC scope turned on. We'll go up here to model, and we're just going to create a simple floor. This will be a 2 by 2 bay floor. We'll say that the spans are 32 feet, and with some level of post-tensioning. And for starters, we'll go ahead and mesh the slab. And after we mesh the slab, we're just going to execute the slab for the default load combinations. So the purpose of this is just to allow the program to bring up the result display settings with some solution already in place. And we can see that this result display dialog looks a little bit different than the current dialog in version 18 and the one that was used in 17. This is now docked to the window. The user can always have the option of pulling that out and moving it. You can also, if we close and we reopen, you have the ability to also hide it and open it. So if you do move the toolbar out, like so, just double click and it will redock in that position on the right side of the screen. So a few new things here. We've categorized the loads in their own tabs. So we have categories for combinations, envelopes, each individual analysis and design option type in terms of the combos, so service, strength, initial. If we go over to loading, load combos, we can see that these are the different classifications, and those would be classified here as the selectable combinations. Under the analysis results, only the available items to be displayed are actually listed in this view. So for example, notice that punching shear is not shown here. If we were to go to floor design and execute the punching shear, that now becomes available. If we go to the option to generate design sections, and then we design those sections, you'll notice that the design section option will then become available. So this gets loaded with results that are available to view graphically. I'll go back and just clean that display. If I go to a contour result, for example, deflection, and let's say I also turn on the column deformations in the R direction, I've expanded manually two particular groups, slab and column, and if I have other things expanded that don't have any selection made, we can use this option here to expand the selected group. So this will essentially collapse everything that is not selected or does not have at least one selection made, and it goes back and condenses to the most efficient view within the tree. If we use the option to clear all, that will basically turn everything off. If we expand, this will expand out every selection, and we can also contract all the selections as well. For each of the different items that are selectable, if we click that item, select the help menu, this will give a description of the item and in some cases some sign convention for that particular result. Under display, you can see if we select the option, there's a new description shown at the bottom of the screen that gives a little more input on what that particular selection item does, and that's also the same here for the settings. So for example, if I select line thickness or contour type or use color range, any of those have more description than they currently do in the current version, commercial version of the software. I'll go back over here to analysis and let's turn on the Z translation, and we notice that the extents of the range are from 0.48 positive to negative 0.79, which is downward deflection. Positive is upward deflection. It follows the convention here for global axis orientation. And if we go and right click on that result, we can change the range. So this might be, for example, 0.2 to 0.48. And that will change the view for that range, and it shows the range in parentheses. It stores that range until we reset it. So if I also go to actions and maybe look at the MYY values, and again I right click and I may want to change that range from negative 15 to 6.74. So there's the new range. Now to reset it, I'll right click again, reset, select OK, and over here for the deformation I would also right click, reset, and select OK. Okay, so that is the result display settings. We're now going to use a different model and look at the punching shear improvements. This model has a bit more variety in terms of the column sizes and some different unique features geometrically, like a drop panel and so on. So from floor design, for the punching shear panel, this is arranged differently. We have now two options: shear design settings and then the option to execute the punching shear. So to get this up to date here, we'll go ahead and mesh this particular model. Under loading load combos, you can see we have a couple of strength combinations which are required. The program only checks punching shear for strength. So we'll go back to analysis, and I'll just execute the analysis for all combinations, including those strength combos. Going back to floor design, we have under the shear design option, we have three new options. One is to extend the critical section to the slab edge. And what this does is this will extend and include the distance from the edge of a column to the edge of the slab when the edge of slab is within 4 times the column thickness. So in the current version, the program essentially ignores that extension, and it assumes that the free edge of the column, when it's a corner or an end edge condition, it assumes that the free edge is the back side of the column. This allows you to include a little more of the critical section and get more capacity out of what concrete is actually there. We'll go ahead and select that. The second option is to limit the rail spacing to 2 times the effective depth of the slab. And this affects how many rails will be assumed around the perimeter of the column. The setting here, which is number of rails per side, would mean that there are only 2 per side, regardless of whether you have a long and a short side of a column. For example, a 48 by 18, you would technically need 4 or 5 rails on the long side, 2 rails on the short side. So this makes sure that that is met in terms of the code requirement. And then also you can choose the option to have the program provide uniform spacing of studs. So we'll go ahead and select those 3 checkboxes. I'll select OK, and I'm going to go under loads, and we need to select a strength combination or the envelope of strength, for example, to produce results for the punching shear. So we'll now go and execute the analysis. We may have already done that. We'll have to actually go ahead and do the punching shear check. Execute punching shear, and you'll notice that gets loaded into the analysis graphical options. I'll select punching shear. Under loads, this actually got reset to the top combination in the list, which is service total. I'll just go back and change that. Now these become available to check. So we'll turn off the finite element shells there, and we'll select the stress check. This color codes the check, so we can see we have a couple of columns here that need reinforcement. One is okay. There's a few others that need reinforcement, and you'll notice this kind of is a muted pink color. This is more bright. The reason for that is we have, for example, this is a lower level column only. These are upper, so we have a mix of gray and pink in this case. That's why in plan you see a color that's slightly more muted over here. So this gives color indication of the status of the column. For punching shear, we get stress check, stress ratios. This is similar to what can be produced now. Under condition, the program will actually show the first critical section for the columns. So for example, you can see for this column and also for this one, since we extended the slab edge or the critical section to the slab edge, it's showing that shape. This critical section actually extends out to this edge and then out to this edge. Same thing here. Here where we have a drop panel, it shows the critical section inside and outside. So this is just an indication, number one, of the classification, meaning interior, end, edge, or corner, or maybe it's not applicable when you have a column connected to a beam or a wall, and also the shape of the critical section. And then finally, under reinforcement, we have a graphical view of the reinforcement design for the particular column. So there's a few things going on here. First, the program will show a scaled arrow as to which direction the rail should be laid out. So in this case, we actually need 3 rails. This is the actual length, so you have some relative indication of its proximity to an adjacent column and whether or not the rails will conflict. We have some notation here. This means that there are 12 total rails. There's 2 rails along the RR direction, which is in the global X direction, 5 rails along the S direction, so that's the long direction here. And we have some indication of the spacing and also the quantity of studs. We have 16 studs at 3 inches on center, and then in the parentheses we have the total rail length. And that's also indicated here in the legend. And then we also show the stud size here. It's a 3/8 inch diameter stud. So graphically you have some indication of the design for the punching shear. If we go over to reports, there's a new report under punching shear XLS reports, and this essentially produces data and output for all of the critical layers that are checked for each of the columns. I'll go ahead and open that. Here we have critical section geometry. If we go back and look at this one column here, let's identify that. That's column 6. For column 6, the program is checking several layers, checking 17 layers. We have the distance from the face of column. We have the effective depths. We have design lengths along the RR and SS directions, design area, section constant, and the gamma factor for the shear distribution from the moment, or the contribution of moment due to the shear. We also have a stress check, and again that's done for each layer. We have shear stress due to direct shear, shear stress due to moments about both axes, total stress, allowable stresses, and stress ratios again for every layer. So this is a departure from previous versions where you only looked at the critical layer, the layer controlling the maximum stress ratio. We have output for areas still required, stud rails, and then required versus provided output as well. Under the reports, punching shear reinforcement report, when we use a uniform spacing option, the program will condense the report, and here we actually have only the enveloped report. So this shows me all the columns, number of rails per side, number of rails, diameter, rail length. This could be used to easily identify which columns could be grouped and scheduled together. So this condensed report can be done in that fashion. Finally, if we go back under floor design, I'm actually going to turn off the option for uniform display, and I'll just go and recheck the model. You can see these graphical results will update. Going back to the reports, historically we've had this report that shows the punching shear for each individual combination. We've also included the envelope of all the strength combinations as a separate report in this view. The program also includes some new graphical options for manual design cuts. So let's go ahead and clean the screen of the punching shear check. We're going to go over to floor design, and instead of maybe using support lines and design strips, maybe we also want to include or just use manual design cuts. We can create manual design cuts, and I'll just create one here along the face of that that column, and then I'll do one here along the face of the wall, and maybe one over here along this span, let's say in the mid-span. So I have 3 manual design cuts. I'll select these, and we're going to design those sections. If we now look at the analysis results again, we can see for a given combination, I'll do strength, dead and live again. We have options here for manual design sections. So we have deformation, we have actions. So if I, for example, turn on the bending actions, this is the integrated bending moment for strength, dead and live, which is indicated also up at the top here for this particular design cut. Also axial force, shear, and so on, shear in plane. We also have contour cuts. So what this option will do is actually give a stress or a distribution of whatever action is selected. If I turn on bending, the program will produce a contour action or a contour cut distribution for that particular result. This is yet to be implemented. It will be included in version 18.1. Under the option for stresses, if we go back and look, for example, at service total, and in this example, we don't have any post-tensioning, so if we were to look at stresses top or bottom, you can see that those are actually reported as 0. I'll go ahead and just create a few tendons here. I'll create tendon 1, tendon 2, maybe tendon 3, and in so doing, I need to reanalyze the model. We'll update the result by designing those sections. And now you can see that for the manual cuts, the stresses now become active. So we can check the stresses, for example, for service total, which is done for service combinations only. We have top stress. Red or green or pink would indicate okay or no good for the stress itself. We have a value, and also this is the stress value, and also a percentage of allowable. So this will show along each of the design cuts. And then also for bottom stress, the same type of a check would be produced. We have stress checks for precompression as well. So these show the amount of precompression in PSI, and then also the percentage of the minimum required, which in this case is 125 PSI. We could also check investigative type responses for the manual cuts. Moment capacity, for example, this will show the capacity of the cut, capacity positive and negative with the demand moments, and also with demand capacity ratios for those cuts. Coming back to the first model, which is the 2-bay by 2-bay model, here we do have quite a bit of post-tensioning both in the banded and the distributed direction. And we're now going to talk about balance loading and the option to investigate for crack deflections. So in this model, we'll start with balance loading. We have a few combinations, service and strength. We're going to go ahead and execute all of those combos again. I'll go ahead and turn the tendons off, and I'll generate the strips for the floor. I'll isolate just the X direction strips. I'll use this middle strip here, and we're going to design the sections for that strip. If we go to design sections now, that becomes active, and we can go to balance loading. There's now a new option that says balance loading simplified. And what that does is if we turn our tendons on and we look at the tendons within that particular strip, we can see that, for example, this is a uniform tendon, and we have some average uplift within the 2 inner bays for that tendon. We have 0.114 kips per foot and 0.114 kips per foot. These are not used in the solution of the pre-stressing load case for the program, but they can be used for the simplified balanced loading check. We actually assume the tendons are resistance, internal resisting elements, and we discretize those to shells for our solution in the finite element method. But we give this mainly as user feedback as to what the average uplift is, and then also if we make changes here to the CG, how does that influence the uplift? This again is used now for the simplified balanced loading check. So any tendon that intersects a design cut at a specific angle, and that angle is actually set here here for simple load balance angle. If I select that, there's a description down here defining what that is. Going back to analysis, using this option now, the program will check the balance loading relative to the summation of the uplift from those tendon shapes. The FEM method uses the summation of the pre-stressing vertical components of force within the tributary relative to the nodes, which is tied to the finite element solution, versus just this notion of using an externally removed, let's say, cable and having equivalent loads applied to a structure, which is the uplift that we saw earlier. Finally, we're going to talk about crack deflection for an existing slab in Adapt Builder 2018. So we're going to take this model, and I'm going to actually add base reinforcement to the model, and we'll go to the option for rebar. I'll just add a bottom mesh of rebar here. Let me do this using the wizard. So we'll say we have a bottom mesh. We'll use number 5s at 12 both ways. And we might want to understand what the crack deflection looks like, or long-term deflection for a system where we add reinforcement. We don't want the program to calculate any reinforcement. And in the current version and previous versions, the user would need to set strength combinations to no code check, turn off the program's analysis and design option under criteria for calculating minimum reinforcement, essentially to suppress the reinforcement calculated by the program, because to check crack deflection you would have to design sections instead of investigate. It was always tied to the design of the sections. Now what we can do is use the option to investigate, which essentially suppresses the calculation of rebar automatically. So in this case, we've added rebar. We're going to go over to loading, load combos. I'm going to add a couple of new combos using this feature down at the bottom, add long-term deflection. And we can see here there's a crack deflection combo that's been added and a long-term. So the program will calculate crack deflection explicitly for this combination. The other combinations, the solution is all based on just the linear elastic response for the slab. So we've added that combo. We'll go back now and execute the analysis. I'm going to generate the design strips, and now we'll go directly to investigate the sections. So this is similar to design. We're just calculating essentially the capacity and storing the composition of each of the design sections when going through that process. So if we were to check this and see if there's any rebar that's needed, there shouldn't be any rebar. If I calculate this, it'll tell me there's no rebar required because the program hasn't designed any. Now we can go to analysis and directly calculate the cracked deflection for the slab. So we have that done. Under the combinations, under loads, you can see if we expand crack deflection. Let me collapse these, and I'll expand cracked. We'll do sustained first. So this is sustained. This is the uncracked using I gross. This is cracked using I effective. If we look at the slab deflection here, we have 0.55, and this slab may not be cracked. It has quite a bit of post-tensioning in it. So we'll look at cracked now, and you can see this stays the same. The best way to check whether it has actually cracked would be to see if there's any loss of stiffness under the action maps. So we can look at reduced rotational stiffness. There's a little bit of cracking, about 7%, about XX, and then about YY, it's identical, meaning there's no cracking. So that gives the user a more direct path to checking crack deflection for existing slabs. If you have any questions about these new improvements, please contact us at support@adaptsoft.com, and these improvements will be included in Builder 18.1 to be released end of February, early March 2019. Thank you.